All right, so you probably know the classic story of the War of the Currents, right? You've got Tesla's AC versus Edison's DC, and spoiler alert, AC wins and goes on to power the entire world. Well, what if I told you that story has a pretty surprising modern-day sequel? Because it turns out DC is making a comeback, and in a way that Edison himself could have only dreamed of. You know, it all kicks off with a fantastic question, just like this one from Reddit. It really gets you thinking and challenges this basic idea a lot of us have about electricity. If DC was supposedly so terrible for long-distance travel, then why on earth are we starting to use it for exactly that? To really get it, we've got to rewind the clock a bit.
So, let's set the scene. We're in the late 19th century. Thomas Edison has his system, direct current, or DC, and it works great for lighting up, say, a few dense city blocks. But it had a problem, a really big one. The whole rivalry was just fierce. I mean, Edison's DC got there first, but Tesla and Westinghouse, they had an ace up their sleeve, alternating current, or AC. And its big trick? It could travel for hundreds of miles with hardly any energy loss. The moment the power from Niagara Falls lit up Buffalo, New York, that was pretty much it. The war was over. AC was officially the king of the grid.
So, okay, why did AC win so completely? Well, it really boiled down to one huge technical advantage. See, with AC, you could easily crank up the voltage for a long trip across the country and then step it back down for safe use in your house, all with this pretty simple device called a transformer. DC, on the other hand, was kind of stuck. It couldn't change voltage easily, so it just bled power over any real distance.
And this comment from Reddit user Ray Gundam just hits the nail on the head. It's the perfect summary. The key thing to understand is that it wasn't really AC versus DC. The real battle was about high voltage. High voltage is what's efficient for transmission, and back then the only tool they had to get to high voltage was the transformer. And you guessed it, transformers only worked with AC. That was the whole ballgame. But what if that changed?
Right, so that was then. Let's fast forward over 100 years, and the game has completely, totally changed. Technology that was pure science fiction in the 1890s has given DC a second act, and believe me, it is taking full advantage. So what was the game changer? It was the invention of powerful solid-state electronics, things like high-power diodes and thyristors. These things basically solved Edison's #1 problem. We can now convert DC to pretty much any voltage we want, and do it super efficiently without any clunky mechanical parts. This one development basically blew the dust off the old book on DC power.
And that brings us to the new champion on the block, high voltage direct current, or HVDC. This is the tech that lets us do what was once flat out impossible, shoot massive amounts of DC power across entire continents and under oceans with even less energy loss than our best AC systems. And look, this isn't just some theory on a whiteboard. As this map shows, a huge HVDC supergrid is being built right now. All those lines you see, those are DC cables connecting the UK, Norway, Germany, and more. They're sharing renewable energy, like wind power, and making the grid more stable for literally millions of people. So why the big switch to DC for these huge projects? Well, HVDC has some serious advantages. It loses way less energy over super long distances, you can cram more power into the same size cable, and it's an absolute lifesaver for long undersea routes where AC starts to have major technical problems. Oh, and it can also act as a kind of universal adapter between two different AC grids that aren't perfectly in sync with each other. It's incredibly useful. And this just gives you a sense of the enormous scale we're talking about. I mean, these are not your neighborhood power lines. These are the giant arteries of a new continent-spanning energy network. But here's the thing. DC's comeback isn't just happening on this massive global scale. It's also happening somewhere much closer to you and me. Okay, so let's zoom all the way in. Let's go from that continent-spanning supergrid to the building that you're sitting in right now. Because the second front in DC's big comeback is happening right inside our own walls. Just think about it for a second. Your laptop, your phone, your TV, even those super efficient LED lights over your head, they don't actually use the AC power that comes out of the wall socket. Nope. Every single one of them has that little power brick or an internal converter that has one job, to turn that AC into the DC that the device actually needs to run. And our current setup is, when you think about it, kinda nuts. It's like taking a flight with a dozen layovers when a direct flight is available. The AC power comes into your building, only to get converted to DC at every single device. And each one of those conversions, in every power brick you own, wastes about 5 to 10% of the energy as heat. A DC microgrid, on the other hand, is that direct flight. One single conversion where the power comes in, and then clean, efficient DC power goes straight to everything.
And what does that actually save? Well, a report from the Pacific Northwest National Laboratory found that a building that makes the switch to a DC microgrid could save between 10 and 18% on its energy bill. That is a huge number when you start thinking about millions of homes and offices. But here's the real kicker. This same report points out that, yeah, the energy savings are great, but the other benefits, they might be even more compelling. So it's not even just about efficiency.
And you might find this surprising, but when they asked industry experts, the top benefit wasn't even the energy savings. Check this out. Reduced installation costs and improved reliability were the biggest draws. And it makes sense, right? If you get rid of all those little AC to DC converters, which are often the first thing to break, your whole system just becomes simpler, tougher, and cheaper to maintain. So there you have it. On one side, you've got a massive HVDC tower powering a continent, and on the other, you've got the simple LED lights in your room, both running on DC. It's this quiet revolution that's happening at every single scale, from the absolutely massive to the tiny.
Okay, so this all sounds pretty amazing, doesn't it? Which leads to the obvious question. If DC is so great now, why aren't all of our houses and offices already wired for it? What's the holdup?
Well, the roadblocks are pretty big. For one, you're going up against 120 years of AC infrastructure. I mean, that's just how things are done. Then there's the problem that nobody's agreed on a single standard DC voltage for inside a building. And maybe most importantly, it's still really hard to go out and buy big-ticket items like an HVAC system or an EV charger that are built to just plug into a DC grid. And all of that creates this classic chicken and egg problem. You know, appliance manufacturers aren't going to pour money into developing DC products if there are no buildings wired for them. And at the same time, builders aren't going to install DC wiring if there are no cool DC products to plug into it. It's just a gridlock of inertia. So I'll end with this final thought. Just about all of our modern technology, our phones, our laptops, our solar panels, our electric cars, it's all fundamentally DC. But our buildings, our infrastructure, they're still stuck in an AC world that was designed over a century ago. So the war of the currents, it's not really over. Round 2 is just getting started. And this time, the battlefield is inside our own homes.